All right, mathletes, here's a 5.2 solving quadratics. Well, what do the solutions represent when we're solving quadratics? Well, they're going to represent where things cross our x-axis, and those things being our parabolas. So notice on the example on the left, we can see we can have an example of a quadratic with one solution. Often those one solutions, we refer to them as a double root. And it's a double root. For instance, if this solution here was when x was equal to 2, our double root is x minus 2 times x minus 2. So they have the same solution, so we call it a double root. Graphically, it looks like it just touches the x-axis once. Remember that this can also be written as x minus 2 squared. On top of options for one solution, we can have graphs like the middle two, where we have two solutions present for those. The third one, we can also have examples of where we have no solutions. So the no solutions happens when our quadratics never cross our x-axis. So that is an example of no solutions. So having a graphic understanding of what's happening will help us through this unit. All right, one of our first methods, like we've talked about before, is our factoring method. We are going to utilize our zero product property, meaning we must set equal to 0 first. So on part A, we notice that it's not equal to 0, so we're going to have to distribute this out and try and put it into standard form. So when I multiply my x through, I'm going to get x squared plus x equals 12. Now I'm going to set it equal to 0, and I get x squared plus x minus 12 is equal to 0. Now I want to choose to factor things that multiply to negative 12 and add to 1. I get 4 and negative 3. Because there's no a value here, the a value is 1, I can just factor it out like this, and I get x plus 4 and x minus 3 equals 0. What makes this equal to 0? Well, when x is equal to negative 4. What makes that equal to 0? Well, when x is equal to 3, I have my two solutions for that quadratic. On part B, what's nice is we already see that it's equal to 0. So therefore, we have to now try and find its factors. We do have an a value, so we got to take that into consideration. A times c is negative 24, and b is 10. Things that multiply to 24, negative 24, and add to 10, meaning 12 and negative 2. So 3x squared. Rewrite this middle term as plus 12x minus 2x and minus 8 equals 0. Notice the things in the red are equivalent. Factor out from your first two terms. I get 3x times x plus 4. Next, I'm going to factor out a negative 2, and I get x plus 4 here equals 0. I know I've done this correctly at this point because I can see that it's x plus 4 and x plus 4 are the same. I factor that out. I'm left with 3x minus 2 is equal to 0. Now zero product property. What makes the left side equal to 0 when x equals negative 4? This middle one we might have to do a little work if we don't recognize it right away, but 3x minus 2, when is it equal to 0? I'll add 2 to both sides. I get 3x is equal to 2, so x must be equal to 2/3. So here are my two solutions for that quadratic. So we have other methods that we can use to solve quadratics, one in which is the square root method. The square root method is nice when we have quantities that are squared and we have no other lingering x's around. So our first rule on these is we must isolate our squared term. So must isolate squared term, meaning we have to make sure that we have only the squared term by itself on one side, just like we see in C. So when we're utilizing the square root method, we need to remember that when we square root something, we have to account for plus and minus solutions. So for instance, on C, if you kind of simplify this and you think of this whole term over here as Z. So if I say Z squared is equal to 64, well, to find what that is, I can square root both sides to undo my squared term, and I get Z is equal to 8, but I also have to remember that when negative 8 is squared, it is also 64. So I have to remember the plus and minus solutions. So we solved an easier problem to identify how to do this one. Well, let's solve this problem here. So 3x minus 1 squared is equal to 64. When I square root both sides, I get 3x minus 1 equals plus or minus the square root of 64. That's going to be 8. So I'm going to branch it out in two solutions. So I can either have a solution of it being positive 8, or I can have a solution on the right being negative 8. So if the right side's plus 8, I'm going to get 3x minus 1 equals 8. Add 1 to both sides, and I get 3x is equal to 9. So x must be equal to 3. On the right side, if it was equal to negative 8, I get 3x minus 1 equals negative 8. Add 1 to both sides, I get 3x is equal to negative 7. Divide by 3, and I get x is equal to negative 7 thirds. So there I have my two solutions for my quadratic. On part D, first thing I need to notice is my squared term isn't isolated, so I need to do some algebra to pull away our layers. I need to deal with the minus 4 and the times 2. So easiest thing here is to deal with the minus 4 by adding 4 to both sides. So then I'm left with 2 times the quantity x minus 3 squared equals 32. Now I'm going to deal with the multiplying by 2 by undoing it. Divide by 2, divide by 2. I get x minus 3 squared is equal to 16. So when I take the square roots of both sides, I get x minus 3 is equal to plus or minus the square root of 16. Well, knowing the square root of 16 is 4, or negative 4, I can break it down into two parts. What happens if the solution is 4 or negative 4? So x minus 3 is the left side, the right side is 4. Add 3 to both sides, I get x is equal to 7. If it was negative 4, I get x minus 3 equals negative 4. Add 3 to both sides, and I get x equals negative 1. So there I have my two solutions for that quadratic. So we have factoring and we have the square root method for solving quadratics. The next one we're going to need to talk about is the quadratic formula method. So to do this, you must consider the quadratic equation and put it into standard form, where our a value is a term with our x squared value, our b value is a term that goes with your x or your linear term, and your c is your constant. So once we put it into that formula, we can determine how many solutions there are. And we'll talk more about this later in the unit. But if we look at the discriminant, which is this, b squared minus 4ac, if that is less than 0, then the quadratic has no real solution, meaning as a picture, we have a graph like this, and it might be like this where it doesn't cross the x-axis, or it could be going down like this. But if b squared minus 4ac is greater than or equal to 0, the real solutions of this equation are given by the quadratic formula. Okay, so the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Notice plus or minus. That's what's going to give rise to two possible solutions when we solve these. So let's go ahead and try this out. First thing I do is I identify my variables. I have A equal to 3, my B is equal to 10, and my C is equal to negative 8. Make sure you are attentive to the details of the sign of those values. We'll have to carry them over. So using the quadratic formula, I get x is equal to negative b, so negative 10, plus or minus the square root of b squared, 10 squared, minus 4 times a times c, all over 2 times a. So from here, we want to simplify things out. So on the left side, I'm going to get, or negative 10, plus or minus, I get square root of 100, negative 4 times 3 times, so negative 4 times 3 times negative 8 is 96, so plus 96 all over 6. Then I can simplify this to negative 10 plus or minus the square root of 196 over 6. Well, then square root of 196 is 14, so I get negative 10 plus or minus 14 over 6. So my solutions, break it up. If it's positive or if it's a minus 14. Negative 10 plus 14, I get 4 over 6, which is equal to 2/3. That's one solution. If it's negative, I get negative 24 over 6, which is equal to negative 4. So these are my solutions for x. I get negative 4 and 2/3. Notice two solutions there for my quadratic. So last one here, f. Again, identify my variables. It must be equal to 0, so I'm good there. So my a is equal to 2, my b is equal to negative 4, and my c is equal to 1. So I have negative b plus or minus square root of negative 4 squared minus 4 times a times c all over 2 times a. All right, simplify. Negative and negative, it's positive 4 plus or minus. Negative 4 squared is 16, so I get the square root of 16. Negative 4 times 2 times 1 is minus 8 all over 4. So simplify this out a little bit more, and I get 4 plus or minus the square root of 8 over 4. Well, 8 can be broken down by perfect squares and simplify my radical to being 4 plus or minus square root of 4 is 2 times the square root of 2 over 4. And everything can be factored out by 2. So if I do 2 times 2 plus or minus the square root of 2 over 2 times 2, there's my 1. So then I can rewrite this as 2 plus or minus the square root of 2 over 2. Because I have a square root here, it's irrational, and I'm fine with leaving the solutions there. If you want decimal solutions, you can pull out your calculator. Let's make this. And I can type them in, and I can say the quantity 2 plus the square root of 2 divided by 2 and get one solution of 1.707. If I hit second enter, what I just typed in is going to be there, but instead of doing addition there, I'm going to change that to subtraction, and I get my second answer as a decimal. All right, well, that's our notes for the night. Make sure you highlight any questions, and I'll see you in class tomorrow.